All right, what we're talking about today is chapter 6.5, which is going to be solving radical equations. What is a radical equation? I don't think it's a cool equation. I think they're cool equations. I mean, I don't know if they really are. A radical equation is any equation that has a variable with a radical or has a variable with a fractional, rational, aka rational exponent. Rational means fractional. Rational means fractional. So here are your possibilities. You could have a square root of x plus 5 is equal to 10. That is a radical equation. Or you could have x plus 2 raised to the 2/3 power is equal to 7. Those are examples of rational, or I should say radical equations. Do we all understand that, yes or no? We good? Okay, steps in solving radical equations. Isolate. You have to write it as a radical. So if I give you a rational exponent, I want you to write it as a radical. Okay? So you're going to isolate the radical. After you've isolated the radical, you are going to square both sides if it is a square root. If it's a cube root, what are you going to do to get rid of the cube root? Cube both sides. What if it's the 7th root? What would you do? Raise it to the 7th power. Do we all understand that? So whatever root it is, that is going to be what you are going to raise it to for power-wise. Number 3, solve the equation for the variable. And number 4, plug and chug. You want to check for extraneous solutions. Well, Mrs. Yoder, what is an extraneous solution? So glad you asked, Mrs. Yoder. Extraneous solution is answers for a radical that appear to work algebraically, but when you plug and chug them back into the equation, they do not work. Do we all understand that? They appear to work, but they really are not correct. Okay? Now, we checked for extraneous solutions back whenever we did something else. Do you remember when we checked for extraneous solutions? What did we do?
Absolute value.
Absolute value. Whenever we did absolute value, we checked for extraneous solutions, remember? So that whole concept is back. Now, when you have this, how do you solve this? Do you see this fractional exponent? I made you write it as power over root. So we're going to get rid of the power and over the root. We're going to write this as a radical. So this is the cube root of x squared is equal to 6. Yes? Do we understand that? Now, how do you get rid of the cube root of something? How do you get rid of the cube root of something? What is the opposite of a radical? A power. So you're going to raise both sides to the power of 3. So power and root cancel out. X squared is equal to 6 cubed. That's a really big number. Take the square root of both sides. X is equal to the square root of 6 cubed. I'm not going to calculate that. We're just going to leave it as that. Don't worry about that. We're going to go on and we're going to do ones that are really going to be homework problems. Okay? No. Okay, this. Isolate. What should I get rid of first? The 2. How do I get rid of the 2? Divide by 2. So if I divide both sides by 2, I have the square root of x cubed is equal to 3. Now, what do I have for my radical there? A square root. So how do I get rid of a square root? Square both sides. So when you square both sides, I'm left with x cubed is equal to, what's 3 squared? 9. Then what do I do? How do I get rid of the power of 3? Take the cube root of each side. So I have x is equal to the cube root of 9. Do we see that, yes or no? Okay, this is all well and good, except for how do we get rid of powers? What is the opposite of a power? No, because it's the cube root, not the square root. Okay? How do I get rid of a power of 2? Take the square root. Well, I would like you to think for a moment. These cancel out on the left-hand side. What is the square root of 9? Well, we have to think for a moment. The square root of 9 is 3, but the property of the square root says what number multiplied by itself gives me 9. Aha, Chase is correct. So I'm going to have positive 3 squared or negative 3 squared is 9. Do we understand that? So when you take the square root, I need you to automatically put plus or minus. Do we get that? This leads me to what we used to do when we did absolute value equations. Do you remember what we did when we had absolute value equations? For example, do you remember how to solve this? How did we solve this? What's that? Case 1 and case 2, do you remember that? He's correct. So case 1 is eliminate the bars and just write the equation. Case 2 is put a negative in front of the left side and make it equal to the right-hand side. Do you remember us doing case 1 and case 2? And why did we do case 1 and case 2? I know where you're going. Give me a moment. Okay? Why did we do case 1 and case 2? Because absolute value is a distance that's measurable, and there are 2 numbers that have the same distance from 0. 5 is 5 units from 0, but what else is 5 units away from 0? Negative 5. So if you remember this, we added 4 to both sides, then divide by 3, and that is your answer. However, what do you guys want to do with this side? You could distribute the negative, but would we have to? We could divide by a -1, and when you divide by a -1, you have 3x minus 4 is equal to -10. So do you see this right here? It's the plus and minus concept. Do we see that? It's the plus and minus concept. Yes? Does not matter which side you put the negative. I always taught you to put it on the left-hand side for inequality purposes. Forgot it. You add 4 to both sides. You have 3x is equal to -6. Divide by 3, and x is equal to -2. Now, if you recall, I made you check for extraneous solutions by plugging and chugging and making sure the right-hand side is equal to the left-hand side, correct? Okay, we're not going to check this one right now, but I wanted to remind you of when we used extraneous solutions. Okay, so let's go into today's homework, into today's problems, today's concept. What is the solution of 3 plus the square root of 2x minus 3 is equal to 8? Well, I'm going to write this in the middle so everybody can see this more easily instead of inside the problem. Now, step 1, it says to isolate the radical. This is the radical. So how do I isolate that? What do I get rid of? How do I get rid of the 3? You're going to subtract 3 from both sides. And this is going to give you the square root of 2x minus 3 is equal to 5. Now what do you do? Why am I squaring both sides? To get rid of your radical. So I'm going to square both sides to eliminate my radical. Power and root cancel out, and I'm left with 2x minus 3 is equal to, what is 5 squared? 25. Do we know how to solve this now? Add 3. And divide by 2, x is equal to 14. Now, I'm going to show you exactly what I want you to do on tonight's homework. Tonight's homework, you are going to go ahead and you are going to type this in your calculator. I understand the assignment that's going to be coming up. Okay? So the problem that you had, I'm going to go to a calculator page, and I'm going to type in there 3 plus the square root of 2 times, what did we say x was? What did we come up with x? 14. Minus 3, get out of the radical, equals 8. And then hit enter. It says it's true. You know what that means? The left-hand side is equal to the right-hand side. Do we all understand that? So we've checked it. We put a check mark beside it. We know that it is right. Okay? There's not a case 2 in this one. And the reason why there's not a case 2 is because I didn't take a square root or a 4th root or a 6th root. You only have case 1 and case 2 whenever you are going to have an even root. The power of 2 and the square root cancel out, which is why I'm left with just 2x minus 3. This 2 and this radical cancel out. They cancel out. That's how what goes away. Let's do it again. Okay, what is the solution of 3 parenthesis x plus 1 to the 2/3 power? Okay, what do we not like about this problem? The fractional exponent of 2/3. Now, we've already heard me say this already once today. Power over root, correct? So we're going to rewrite this. The 3 has an exponent of 1, so it stays on the outside. The root is a 2, and the power is the root is a 3, and the power is a 2. So you're going to have 3 times the cube root of x plus 1 squared is equal to 12. I need to isolate, so what do? I am going to divide both sides by 3, and I have the cube root of x plus 1 squared is equal to 4. Now what? Why am I cubing both sides? Because I have a root, and the opposite of a root is a power. So now what's going to cancel out is going to be this root with that power. But what you do to one side, you must do to the other. So I have x plus 1 quantity squared is equal to 4 times 4, which is 16, times 4, which is 64. Does everybody see that? Now, I'm going to clone this page because at this point, there's 2 ways that you can go about doing this problem. There are 2 ways you can go about doing this problem. And neither way is more correct than the other. It just depends upon what your brain thinks to do. So I would like you to raise your hand and tell me what you would like to do next. Paul, what? How do I get rid of the power of 2? Square root it. So if I square root both sides, notice again the power and the root cancel out, and I'm left with an x plus 1 is equal to, did I take an even root? So what must I put there? Plus or minus, and what is the square root of 64? 8. Do you see that? So we are going to have 2 different equations. I'm going to have x plus 1 is equal to positive 8, and x plus 1 is equal to negative 8. Do we see that? Because I took the square root of 64, and there are 2 numbers that can give me a positive 64. Negative 8 times negative 8, or positive 8 times positive 8. If I subtract the 1 from both sides, I have x is equal to 7. If I subtract the 1, I have x is equal to negative 9. Now, what do I need to do? I need to type it in the calculator. So I'm going to go back to my calculator, and I'm going to type in my problem. And my problem is 3 times parenthesis x, which is negative 9, plus 1 raised to the, sorry, wrong place, raised to the 2 divided by 3 is equal to 8. Nope. What is it equal to? 12. What does that say? False. What does that mean? Negative 9 does not work. I'm going to arrow up twice and hit enter, and I'm going to replace negative 9 with what? Negative 7. Maybe. And I'm going to hit enter. And what does that one say? It is a positive 7. Sorry, guys. It doesn't like to delete right there. And that one's true. Do we see that? Yes? So we go back over to the example. And that means this is not correct, and this one is. Yes? Okay, now remember I told you there were 2 possible ways to do this. Yes? Here's the other way. Instead of taking the square root of both sides, what can I do? What does the squared mean? To write it down 2 times with 2 binomials. And then what would you instinctively want to do with those 2 binomials? What does that mean? FOIL them, right? X squared plus 2x plus 1 is equal to 64. Then what? Subtract the 64 to give you x squared plus 2x minus 63 is equal to 0. And then put into 2 binomials. So x and x, and then 9 and 7, plus and minus, so x is equal to negative 9, and x is equal to positive 7. Now, my question to you is which method do you think is easier? This one right here is much smaller numbers for calculation. The second way, which is what I'm talking about right here, this is foundational information which you've already learned and you're reapplying. So there's no new information here. Does that make sense? They both will get you the same answer. It's a matter of what way is your brain going to latch onto. Do we all understand that? Okay? You only have the plus or minus when you are doing an even root. Yes? They both work without a doubt. Okay? Now, let's go to the next example. Next example is right here. So if I rewrite this, 3 times the 5th root of x plus 1 quantity cubed plus 1 is equal to 25. So what should I do first? No. You've got to subtract 1 first. So if I do that, I'm left with 3 times the 5th root of x plus 1 cubed is equal to 24. Then what? Now divide by 3. So if you divide by 3 now, this is going to give you the 5th root of x plus 1 cubed is equal to 24 divided by 3 is 8. Now what? What does that mean? Put a 5 on it. Put it to a power of 5. Okay? So we're going to raise both sides to a power of 5. Correct? Do we see that? So what you're going to notice here is the power of 5 and the root of 5 cancel out, and what remains is x plus 1 quantity cubed is equal to 8 to the 5th power. I do not know what 8 to the 5th power is, and I'm not going to grab a calculator to do that right now. And the reason why I'm not going to is because what is the next step that I should take to solve for x? The cube root of that. So if I take the cube root of both sides, the power and root cancel out, and you're left with x plus 1 is equal to. Now, if you remember whenever I taught you powers and roots, I said that they are commutative, meaning it doesn't matter if you do the root or the power first. Which way makes the calculation smaller for your head? Doing the power first or doing the root first? Which way makes the calculation smaller for your head? By doing the root first. So we're going to take the cube root of 8 and then raise it to the 5th power. So what is the cube root of 8? What number multiplied by itself 3 times is the number 8? 2 times 2 is 4 times 2 is 8. So I have x plus 1 is equal to 2 raised to the 5th power now. 2 times 2 is 4 times 2 is 8 times 2 is 32. So I have x plus 1 is equal to 32. Do we see that? Now how do I solve for x? Subtract 1, so x is equal to 31. Am I done? What do I need to do? I need to go back to the calculator and I need to plug and chug. So I'm going to get out the original problem, which is going to be 3 times the 5th root of parentheses, x is 31 plus 1 cubed. Get out of there. Plus 1 equals 25. And hit enter. And what does it tell you? True. So therefore, what can we conclude? That x equals 31 is an answer that gives a true outcome. Do we all understand that? Okay. How do I do this problem? How is it different? Trey, how is this problem different? Is there just one x on the other side? There's a variable on each side. Do we understand that? Do you remember when we did absolute values and we had variables on both sides? This is whenever we had extraneous solutions. Do you remember that? Okay. So in this case, we're still going to follow the same rules that we have been following. So what's the first rule that we started with? We need to isolate the radicals. So we're going to add 5 to both sides. Very good. So at this point, is my radical isolated?
Yeah.
Yes. So what should I do next? How do I get rid of that square root symbol, which is going to be raising it to a power of 2 on both sides? Correct? Power and root cancel out. I'm left with x plus 7 is equal to x plus 5 squared. What does the squared mean? You have to write it down twice because what are you going to do? You're going to have to FOIL that, right? So I have x plus 7 is equal to x squared plus 5x plus 5x plus 25. Yes? Combine like terms? Yes, Josh? Are we doing this on our paper? I like to see it written. Write it. Write it. Now what do I do? Seven equal to 0. So how do I do that? Subtract the x from both sides. Subtract the 7 from both sides. And add straight down. The x's and the 7's cancel out and I'm left with 0 is equal to x squared plus 9x plus 18. Now what? Factor this into two binomials. 0 is equal to, how do I break down x squared? X and x, I need a positive 18 and a positive middle, so they're plus plus factors of 18 that add to 9. 6 and 3. So x plus 6 is equal to 0 and x plus 3 is equal to 0. X is equal to negative 6, x is equal to negative 3. Am I done? What should I do? I need to plug this in to confirm that one is equal or they both are equal or none of them are equal, correct? So if that's the case, I go right here and I say, all right, the square root. What is x equal to? What was the first one? Negative 6 plus 7, arrow out of there. minus 5 equals negative 6 and hit enter. That is false. So what are we going to do with negative 6? We're going to go ahead and put an X over that and say it doesn't equal. I'm going to arrow twice. And I'm going to turn this into a negative 3 plus 7. Get out of there. And change this to a negative 3 and hit enter. And that one is true. Do we see that? So therefore, we have our 2 answers. However, only one of them work. An X over this one and a check mark on that one. Do we understand that? Yes? Last scenario. What do you notice about this problem? Fractional exponent. So what does a fractional exponent mean in your head? Power over root. So my power is a 1 and my root is a 2. So this is what I have. Now, do you remember when we did absolute values? I said always check to see if it's possible. What did that mean? Absolute value was always and forever. What was the outcome of an absolute value? Positive. Could it ever equal an outcome being negative? No. What is the outcome of a square root? What's the square root of 16? What's the square root of 9? What's the square root of 64? Why are you not telling me negatives? Because what number system do you go into if you get a negative number? Imaginary. So this always has to be positive, and that's going to equal a negative. When is that true? Sometimes, always, or never? That is never true. So therefore, what is my solution? There is no answer to that. Okay, so let's go ahead and solve this, because you're going to go ahead and square both sides. Okay, so that gives me a 2x plus a 5 is equal to, what's negative 10 squared? Okay, perfect. Then we're going to go ahead and subtract 5, right? Okay, so 2x is equal to 95. Then what? Okay, so x is equal to 95 over 2. Then what would you do with that number? You would plug it in. So let's go ahead and plug that in, because you said there's an answer. So let's go ahead and check that. So I have parenthesis 2 times 95 divided by 2 plus 5 raised to the 1 divided by 2 power, and that equals negative 10. Hit enter. False.
I don't understand.
Because whenever you calculate it out, can you ever take the square root of a number and it become negative? And I'm telling you that a square root is going to equal a negative number, and guess what? That's never possible. So you can do the blue and plug and chug like you did and get no solution and go like that. Or you can logically think through it and say, hey, that's the square root, and I'm saying the square root has to be positive, and that's going to equal a negative, and that can never happen, so therefore no solution. I like the red because it's a lot less calculational work. But in the event that you forget it, you'll get it this way as well. Okay? This is the only thing that we're taking the test over. So this gives you a huge opportunity to get your grade up. Now listen. Are we listening? Stop moving. We have 6-5 worksheet, Math Excel work, Math Excel, and a test yet. 4 things before the end of the year. Okay? I'm going to pass out your homework to you now. Give me 1 second. Give me 1 second.